So in this video, we're going to review something you should learn last year in algebra, which is simplifying square roots. You had a whole unit on this in algebra, but we are only going to focus on one part of it that we're going to use in geometry. So your objective is that you can put square roots in simplest radical form, which I'll explain again what that means. So let's look at a square root in more detail. So what does that mean when you're actually taking the square root of 25? Well, that means what two numbers times itself equal 25? Well, you should know the answer is 5 times 5. So my final answer is 5. 5 times itself is 25. Or you can think of it as 5 squared. So instead of saying what two numbers times itself equals 25, you can think what number squared is 25. So the answer is 5. There's also another answer, which we will only look at the positive in geometry just because we're dealing with lengths. However, negative 5 is also an answer because negative 5 squared is 25. So simplest radical form for square roots. When I say in your directions you need to put something in simplest radical form, you are looking at that there are no perfect squares under the radicand, and the radicand is the root part. And I'm talking about 1's a perfect square, 4, 9, because that's 3 squared, 16, and 25, and so forth. There are no radicals in the denominator. So if you have a fraction, you cannot have a square root or any root in the denominator. It is a decimal, which is a big math no-no. Or there are no fraction or decimals under the square root. So you can't have this situation where you have like 1/3 and the whole thing is another root. We're going to learn how to simplify each of these in the next slides. So simplify each expression. Now, my analogy is that you have to think of the root as a jail. And most prisoners do not want to be in jail, so they want to break out. And to break out, you need 2 of a kind. Alright? Once you have 2 of a kind, you can break out. You cannot break out with 3. You only can break out with 2 with a square root. Little 2's right here. So to do that, we're going to do a factor tree. So we go 90. 90 is 9 times 10. And we break it down until we have only prime numbers. Alright. That's my very elaborate prime number. It keeps jumping on me. Let me erase, clean this up a bit. So we keep breaking down because 9 and 10 are composite numbers, which means there are still two numbers that multiply together to be it. So we have 3 and 3. Those are prime. I like to circle my primes because then I know I'm done. And then 10 is 2 and 5. Alright. So, to figure out what this simplifies down to, if I have a pair of numbers, they can go outside. Well, I have a pair of 3's. So I just bring a single 3 outside, not both of them. And then inside, the 2 and the 5 do not have a pair. So I go 2 times 5 inside, and then I get 3 square root of 10. Now you might be thinking to yourself, well, why do we need to know this in geometry? Well, when you're doing this, this is called the exact answer. 3 square root of 10. Problem with roots is that they're decimals that go on forever. They're irrational numbers. And if you keep having a whole bunch of decimals that you keep rounding and simplifying, your measurements towards the end go off. So it's better to stay in simplest radical form. And I always give the analogy, you wouldn't want somebody building your house that was rounding the entire time. You want somebody who's doing exact calculations. So let's look at 192. Well, I know 3 goes into it. And 3 goes in there 64 times. And 3 is prime, so I'm going to circle 3. 64 is 8 and 8. Then we have 2 and 4. And over here we have 2 and 4. These 2's are prime. And then this is 2 and 2. Alright. Well, we have a lot of pairs on this one. So I have one pair of twos, so I have 1, 2 that gets to go outside. I have a second pair of twos, so I have a second 2 that goes outside the radical. And then I have a third pair of twos. And then I have a 3. A 3 does not have anyone to break out of jail to, so that is a 3 on the inside. So I multiply the 2 together. It's always multiplication. 2 times 2 times 2 is 8. Square root of 3. Hopefully this is becoming really familiar with you. You're kind of recalling it from last year because you did do this last year. Alright, so the last example like this is 576. So breaking this down, I can start very simple. I know it's even because it ends in 6. So that is 2, 8, and 8. I know 9 actually divides into this. Oh, I gotta circle 2. That is 332. Those are both composite numbers, so we have 3 and 3. And this is 8 and 4. 4 and 2. 2 and 2. Alright. To save time, I'm just not going to circle everything. So I have a pair of 3s. I have a pair of 2s. A pair of 2s. And then I have another pair of 2s here. So notice everything has a pair. So then my answer is 2 times 3 times 2 times 2. And I don't use the root because nothing's left inside. If you don't have a need for the jail, you don't have one. So you go 2 times 3 is 6 times 4. My answer is 24. Which makes 576 a perfect square. When it comes out even, it's a perfect square. Alright, so the next one is when we have numbers already on the outside. So what do we do there? So you have to think to yourself, you're either on the inside or you're outside of the square roots. The insides go together and the outsides go together. The people in jail associate with people in jail. The people outside of jail associate with people outside of jail. So here we have 5 square root of 28. The 5's already on the outside, so I'm going to see who joins this. Alright. So then I have 4 and 7. 2 and 2. I have a pair of 2s, so the 2 joins the 5, so I take this times 2, which gives me 10, and then the 7 stays in. So 10 root 7. So on E, we have 8 and 6 on the outside, so I can multiply those together because they're both on the outside, so that's 48. 2 and 6 on the inside, so that's square root of 12. And then I can break down square root of 12, which is 6 and 2, or you could do 3 and 4. It does not matter what pairs you start off with, you're going to get the same answer. And 3 and 2. So I have a pair of 2s. So I go 2 times 48, which is 96. So 48's already on the outside, and we multiply square root of 3. And again, it's very possible that you don't end up with anything on the inside and you just have a number. Alright, so the last thing is what happens if you have a root in the denominator. And this is something called rationalizing the denominator. You're getting the square root out of the denominator. And to do that, you are going to multiply whatever's in the denominator to the top and bottom. This is called rationalizing the denominator. Making it a rational number, because right now it's irrational. That's where the name comes from. So we have root 2 to the top and root 2 to the bottom. I don't multiply anything with a 1. And notice what number I'm actually multiplying by. Anytime you have a number divided by itself, this is just 1. So we're not changing the problem if you're looking at this mathematically. So 1, square root of 2, 1's on the outside, 2's on the inside. Well, that's square root of 2. Then here, we have square root of 2 times square root of 2, which is square root of 4. Or you can think of that you have a pair of 2's. So it's just 2. Or if you have square root of 4, it's a perfect square, is 2. So I have square root of 2 over 2. That's That's a 2 there. So let's do this one. I multiply my root that's in the denominator, top and bottom. Now, if I did not have a root in the denominator, I do not need to do this. It's only when you have a root. We cannot have our square root in the denominator, in the bottom. So I go 1 times root 6, which is root 6. And root 6 times root 6 is root 36. The square root of 36. Because they're both still on the inside, which is 6. Or you can think you have a pair. And this is what we want. Now it's rationalized because there's a rational number in the denominator. There is a nice number, not a root. So that is my final answer. Alright, so let's look at a few of simplifying it completely. I have a root in the bottom, square root of 5, so I'm going to multiply it to top and bottom. Alright, so I have 2 square root of 5, which is 2 root 5, over root 5 times root 5 is root 25, which is 5. I can look here. I always should look to see if 2 and 5 simplify, but they are not. I also should look to see if the root simplifies. Root 5 is prime. That is my final answer. Here I have root 3 in the bottom, so I'm going to multiply it to the top. Into the bottom. And then 3, square root of 3, over root 3 times root 3 is 3. Now take a look on the outside. I have a fraction 3 divided by 3. Well, if I simplify this fraction, they both simplified down to 1, which 1 times root 3 is root 3 divided by 1 is still root 3 is my final answer. Alright, so now I have an entire fraction under the denominator. There's a few ways you could go about doing this problem. I'm going to do the way most students like to do it, but you may come up with a different way. When you have a root like this, because they're both under the root, you are allowed to split the root. I can go over more details in class if you wish of why this is allowed. But the kind of long story short, they're both on the inside, they're still both on the inside. You're either in or you're out, and these are both in and these are both in, so that is okay. Whoop. My pen going crazy again. So now I have a root 24 on the bottom, so I multiply by root 24 to the top. Okay, so I can go 4 times root 24, which is 96, over 24. Then go 96. You can split this up, 3 and 32, 8 and 4, 4 and 2, 2 and 2, and 2 and 2. Alright, so I have 1 pairs of 2's, 2, and a 2 and a 3 separate, so that's 2 times 2, which is 4, square root of 6, and then I still have that 24 on the bottom. Alright, so now I gotta look at my outside, my inside numbers. My outside numbers can simplify 4 and 24. They both are divisible by 4. So that is 6. So this is root 6 over 6. That's my final answer. Alright, so an I, again, I can split it. I'm trying to give you a bunch of examples. This would be a good chance if you think you got the first one to try this one. See if you got it right. Square root of 20. So you have square root of 20 over square root of 20. 3 and 20 are still on the inside, so it's still square root of 60. Once you're in until you have a pair. And root 20 times root 20, we have a pair, so that is 20. Alright, so 60, root 60 I'm going to do over here, breaks down to 6 and 10, 3 and 2, 2 and 5. Alright, so you have a pair of 2's, which is 2. Square root of 15 over 20. Well, this breaks down into 1 and 10. So I get square root of 15 over 10. That's my final answer. I'm going to stop there because these two are very similar if you want to practice them at your own, but I think if you know these two examples, all these are is instead of one fraction, they're now here, so you multiply by root 25 to top and bottom, root 20 top and bottom, and then simplify. Alright, so review, this is simplest radical form, and this should become familiar with you because you did do this in algebra, and I know if you attended West Fargo, everyone did this. We had a whole unit on it. Thing to remember is what makes simplest radical form. Your square roots, and then root a times root a is a. This is a very important fact, and rationalize the denominator. We are going to be applying this a lot of times in this next sections. I'm going to say put your answers in simplest radical form, so you're going to need to know how to do each one of these. Reminder to do reflection so you get credit for watching this video.